It's on.
Thank you. All right, thank you all for attending this year's meeting of the Task Force on Benchmarks for Validating Emerging Power System Algorithms. I'm Carlton Coffrin, I'm the chair of this task force, and it's my pleasure to have Dan Malzahn as a co-host of this meeting, helping with the online version. So here's an agenda for today's talk. I'm going to give a brief introduction to the task force and its goals. I'll do some announcements of interesting things I think are going on in the community that are related to this effort, a progress report on what's happened in the past year, and then we'll do a fairly lengthy overview of updates to the pglib OPF benchmark library. And in the end, I've asked Clayton Barrows to give a brief update on this RTS GMLC test case that he works on because I think it's a very relevant and interesting benchmark test case. So brief introduction, what's this task force about? It's all about algorithmic benchmarking, and how do you do this in practice? Usually what you do is you take a collection of hopefully interesting test cases, you run them on different types of algorithms, and then you have some performance metrics which you evaluate for each of these algorithms. And the goal is to run something like a competition across all the algorithms and conclude, algorithm 2 is the new best informed because we tested it on these interesting test cases and it had the best metrics performance. And this is nothing new. A lot of different algorithm communities developed libraries for doing this kind of benchmarking. So you have things like the MIP lib, the satisfiability lib, the constraint satisfaction lib. And the basic premise of this task force is to do the same thing, but in the power systems context. So we have developed over several years this thing called Power Grid Library, or PGLib, which is a variety of different benchmarks for power system problems. The core features of these PGLib benchmarks are that we have a very specific problem specification. So there's a mathematical model of what the algorithmic task is. There's a standard data format for all the data sets that occur in a repository, and then all the data is released under Creative Commons, which makes it easy to share and modify as part of the scientific discourse. The flagship repository for this task force is this thing called pglib OPF. The version 19.05, which was last year's version, has 45 base networks and a total of 135 cases. They're curated in the map power data format, and you can have a look at it here. We now have 2 more repositories, one on unit commitment and one on OPF with HVDC lines, which I'll touch on briefly. So on to announcements. There are these grid repositories that have been developed by ARPA-E as part of the grid data program. It's bettergrids.org and egriddata.org. I've noticed that these continue to have interesting test cases posted on them. So if you're looking for network data, I would definitely recommend checking them out and seeing what's on there that may be of use to you. I think these are great efforts and great repositories that are out there with quite a bit broader goals than this task force, but definitely worth checking out. The RTS 96 case has been revised into this RTS GMLC case, and it continues to be updated and improved. So I've asked Clayton Barrows to speak a little bit at the end of this about the updates they've made in the past year and how that whole case is going. Another interesting development is that ARPA-E has been running a grid optimization competition. The first challenge is a big source of new data for this effort, but it's important to note that challenge 2 is underway, recently announced. There's approximately $3 million in prizes. So I think it's valuable to watch this space not only as a source of new network data sets, but also you could participate in this competition and potentially win a bunch of money. So I encourage you to go check it out at, I think it's gridoptimization.energy.gov. Another important announcement is that curators are always welcome to this task force effort. I would love to see more benchmarks and more benchmark curators working with this task force. The basic steps to get involved, if you want to develop a new benchmark library, is you have to write a mathematical specification of what this favorite problem of yours is that you want to benchmark. You need to encode some problem examples in a standardized data format, and then get your collection approved by this task force at the next general meeting. I think there are some really pressing needs in the research community for benchmark problems on things like stochastic OPF, three-phase OPF, and security-constrained OPF. So if any of those topics are of interest to you, I think you would have a very big impact by helping to curate a benchmark set around these. All right, so that's the end of the announcements. Let's do a little progress report. Currently in PGLib, we have 3 benchmark repositories, one on OPF, one on unit commitment, and one on OPF with HVDC lines. And I'm going to go through these one at a time. This shows you the 2-week visitation of the OPF with HVDC lines statistics on the GitHub repository. So this key thing I want you to look at here is the number of views and the number of unique visitors. So this repository had about 14 unique visitors, about 1 a day, in the course of a 2-week window. So I think that's pretty good. This is maybe not the most popular problem to be studying in the community. So I'm not surprised. It's also a fairly new one. So that's the status of that one. If we look at unit commitment, it's gotten a lot of attention actually, which is good news. So in the past 2 weeks, it had about 43 unique visitors and 175 views, which would suggest that people are viewing different parts of the repository. So that's, I think, a fantastic outcome for a first year of a repository. And then if we look at the OPF benchmark, we're up to 145 unique visitors in a 2-week period, which is shocking to me. I don't know where 145 people could come from every 2 weeks that are interested in OPF problems, but that's great news. And what I'm showing here with the little pluses is the delta from last year. So for example, we've got 20 new stars on the repository, which is something like likes. We have approximately 50 more views per 2-week period than we had last year, and 80 plus unique visitors from last year. So a really big uptick in interest. My guess here is this is a combination of just longevity of having the repository active and also releasing the technical report about this repository, which would help drive people to find it. So speaking of the technical report, last year, we released a 17-page technical report with 100 plus references and 20 contributors, lots of different institutions represented. This is all the different folks who had contributed data to this particular repository effort. And in its first year of being online, it's gained 21 citations, which I think for power systems is a pretty remarkable number. And I'm looking forward to seeing that grow in the next couple of years. So I think that report has been a good effort and really worth it because of the citations it's accrued in the first year. In terms of updates, there have been no significant issues about any of the repositories reported on GitHub. I've answered a couple of questions about different things over the year, but nobody found a serious bug. That's not surprising, given that especially the OPF repository has been available for quite some time. The next point in the agenda is that I'm going to propose to add 18 new networks to this PGLib OPF repository that were produced by the ARPA Grid Optimization Competition Challenge 1. So let's just dive in and talk about the updates that I'm proposing. So I mentioned this briefly, but in the 2018 to 2019 timeframe, ARPA-E ran the Grid Optimization Competition Challenge 1 and distributed approximately $4 million in prizes for security-constrained OPF algorithms. As part of this, they developed and released publicly hundreds of networks that ranged in sizes from, say, 500 buses to 30,000 buses. And there are unique network topologies amongst all of these hundreds of different scenarios. And then there's like different load profiles or other types of conditions for each of these different unique networks. These were developed by 3 distinct data efforts. So there was a team at Texas A&M, University of Wisconsin-Madison, and Pacific Northwest National Laboratory. So what I did was I looked at all the publicly released data sets for the final event of this competition, and then I tried to hand pick a subset which was interesting and different so that it would be good for getting a diversity of inputs for a benchmarking exercise. And in doing that, I was able to identify 18 unique synthetic network cases. And they basically, it's like one network case from each kind of big category of scenarios. And these range from 500 to 30,000 buses. I'll also note that in their native form, these data sets were exactly as the same as MapPower data format. So like it supported some amount of controllable shunts. They supported piecewise linear cost functions instead of polynomial cost functions. So I did have to do some data translation to basically move these network data sets into the format of this particular benchmark library. So in the end, I'm proposing to add these 18 new networks, which were produced by the grid optimization competition and were used in the final event for evaluating the competitors. So you can see there's quite a range of bus sizes. The case number is the number of buses in the network. And I did the standard validation procedures for any new network going into this archive. So all of the networks are AC feasible. And I think what's very exciting to me now is that we're starting to get into sizes of networks where the runtimes are quite interesting. So if you look at these largest cases, then the runtimes for solving with like off-the-shelf nonlinear optimization tool like IPOpt is starting to get into the order of 1 to 2 minutes, maybe 3 minutes in the extreme case. And that's very exciting for algorithmic development because I think there's room here to reduce those runtimes through more sophisticated algorithms, which has been a very high bar in previous cases because they are solving in like 10 seconds or 20 seconds. So these are the results for the base cases that came out of the competition. If you look at the column on optimality gaps, which is like right around here, some are 2%, that's pretty interesting, but a lot of them are less than 1%. And this is one of the reasons why in this benchmark library we have modified versions of the cases which are designed to have larger optimality gaps. So we have the API and SAD modified versions of the cases. And what you can see, so this is the same subset of proposed new cases, but for those 2 categories, is that these optimality gaps are very interesting. So especially in the API case, we're seeing large networks with optimality gaps of more than 10%. And that presents a huge challenge for the convex relaxation community who's studying convex relaxations of ACOPF. So that's very exciting. We have similar trends with the SAD case as well. Maybe not as dramatic gaps, but still quite significant, something to, to consider. Now, as part of this effort to add these networks, I observed that we're going to have a lot of networks. And I don't think we need all of them to do accurate benchmarking. So for the first time, I'm proposing to remove some networks from the test case because I think they're bringing very minimal value to the benchmark library. And this is something that's very common in the other benchmark libraries that we've referenced in this project, like the MIP-lib is a great example where they're constantly changing the set of benchmarks to kind of stay at the frontier of where the algorithms are. In power systems, we've usually been starved for open access data sets, so we haven't had the luxury of removing them. But now I think we actually have enough that it makes sense. So I'm proposing to remove this 30 bus case. And the main reason here is I did a look at the 3 30 bus cases we have. They're all fairly similar to one another. And I thought this particular one was only bringing marginal value over the other 2 30 buses. So I proposed to remove that. And then the other 3 cases were different cases that had been produced by earlier data efforts. and I compared them to the data sets which were used in this grid optimization competition, and the results were similar or identical. So my interpretation was that these grid optimization competition versions of the data sets were just improved versions of a similar methodology for making data sets. So we might as well go with the latest version that had been produced, which is this GOC version. So with all those changes, we are proposing to go from 45 base networks to 57 base networks. We're increasing from a maximum of 10,000 buses to 30,000 buses. On the left, you're seeing the distribution of where the different networks come from in the archive. And then this is what it's looking like in the proposed version. So now about 1/3 are coming from these grid optimization cases because we got 18 networks in one foul swoop, which is quite a large number. But after this, I would say the different networks are fairly evenly distributed, which I think is great news. It's like kind of like a uniform distribution over all the different ways or data sources we have for realistic transmission networks. So that's kind of the end of the overview of the updates. Before we go into the discussion phase, I wanted to invite Clayton Barrows to unmute his mic and make some comments on this RTS GMLC case that he's been developing. I'll just introduce it as far as I'm concerned, the best open access multi-period network data set. And that's where the real unique value here comes, is that getting multi-period data is incredibly challenging in practice. It has very detailed generator models, which makes it great for unit commitment studies. It also has this wind and solar resource data, which is in the image to the right. So if you want to do renewable integration studies, that data is also very tedious and hard to come by, but it's available for you. And then it has 1 year of time series, which includes both forecasts and actuals. So you can really use this data set to do a simulation of a market or a power system. So Clayton, would you like to make some comments on what are the updates that have been going on here?
Yeah, I can make a few comments. So this repository linked here has the original, or sort of the source data, as we call it, in CSV format. And then additionally, there are a number of formatted data sets that basically convert that source data to various different formats, including PSSE and map power and power simulations and Prescient and Plexus and a few others. And so one activity that is ongoing and is far from complete, but is to update several of those conversions to make them more automated and easier to maintain. So that's a significant update, and one that I am reaching out to contributors who have made those conversions in the past to try and kind of get some help updating what they've contributed, and actively trying to add more conversions as well. I think it's useful for people to have easy access to already formatted data sets for a particular tool they're using. In addition, there's been various identifications of bad data or poor quality data that we've tried to resolve, including nonsensical ramp rates and costs, and sometimes inconsistent costs and heat rate calculations. And then there's been a handful of areas where we've identified needed, or areas for improvement. One of them is updating the legacy wind and solar and load time series information that are included. So at NREL, we have better and more recent data sets that we could draw from to populate the wind and solar and load data. And so that effort has been identified and just has not actually taken place. So, and then there's been a number of kind of requests for added features, including things like data for capacity expansion, finer resolution data suitable for AGC and area control error modeling, uh, generator dynamic information. I mean, there's a number of things that we have been requested to do, and I just don't have a lot of bandwidth to do it all. So would certainly welcome any contributions that would want to help with some of that.
And I'll just ask a question for you, Clayton. If someone wants to use this data set for their research, is it as simple as just pull down the repository, load it one of the formats that's in there, and you're ready to go?
Yes, with some caveats to some of the formatting is suitable for some analysis and not for others. So the formatted data sets are usually formatted with a specific purpose in mind. So they might implement a certain time period within the time series, or they might implement a certain view of generator costs or the problem that you're trying to specify. But yes, you're in terms of licensing, it's pretty unrestricted. You're free to do whatever you want with it, as long as you don't hold NREL or me liable. And then but yeah, you can clone or download it and get started.
Great. Thanks a lot for that update, Clayton.
Mm-hmm.
So with that, we'll move on to the discussion phase. I guess I would recommend we start with the questions in the chat. Dan, do you want to start relaying those?
Yeah, so Carlton, I think the main question that people have asked, or topic, I guess, that people have brought up is about the benchmark, the comparisons for your optimality gaps and the different power flow representations. So in your table, you had the QC relaxation, the SOCP relaxation, I forget exactly what else, DC power flow. So both Panos and Carlo were asking about questions about alternatives or additional power flow benchmarks or power flow models.
Mm-hmm.
I don't know if Carlo and Panos, if I've communicated your question appropriately, or if I haven't, please feel free to unmute and clarify. But that seems to be the main topic people brought up.
Okay, well, let me make an initial response to this. So the first remark is that the goal here is not to do like a proper study of convex relaxations in the context of AC optimal power flow. I'm just using these as a probe to say, is this test case interesting? Or do the constraints in this network actually matter? Is another kind of proxy that you get from this information. In terms of these particular relaxations, so the SOC is the weakest one, nearly, let's say, the weakest one out there. So you could potentially close this significantly using more sophisticated methods like the ones that Dan has developed over the years. But if this gap is small, it means there is like nothing interesting to do from a convex relaxation standpoint. It also means that the AC solution that we found is near optimal. So for example, if we look at this particular case right here, we're showing with this very weak relaxation a less than a 1% gap, which implies that this AC feasible solution is very near global optimality. So if your exercise is benchmarking the performance of AC OPF, this is probably still an interesting test case for you. If your exercise is designing a tighter convex relaxation or a method related to that, this is not an interesting case for you because there isn't a significant gap to close. You could maybe make a very nuanced argument about closing 0.76, but you better be careful about it. Where, for example, this case right here, if you're doing convex relaxation research is a great candidate because it looks like there's a huge gain to be made between the AC solution and the relaxation. This may be due to the fact that the AC solution is far from optimal. This may be due to the lower bound, being weak, and that's an open question that someone could study with this benchmark library. So with that, are there follow-up questions?
Hey, Carlton. Thanks for having me here. Thanks for the invitation, for joining the group. My consideration was not that much on the side of the relaxations and the ACOPF and the AC solutions as exact solutions, but on the linear approximations. Since on the linear approximations, we divert from the feasible region, and since linear approximations are still the industry staple, maybe I was considering another column in these tables of these test cases where with either a gap or another kind of metric, we could be benchmarking linear approximations. As I've been actually through my recent work seeing recently, there are a ton, like maybe dozens of different linear approximations, each one of them claiming different guarantees, some offering proofs and so on and so forth. And for anyone who has tried 5 different networks would know that the guarantees, the theoretical guarantees, go completely away like just in a second, because with linear approximations, the approximation is always either on the flows or on the network. So the approximation is affected by a multitude of reasons. So I was thinking of a framework of assessment of linear approximations in the context of the existing benchmarks. So with these benchmarks, no update, no change, we just devise or find out there in the literature, if there is one, some kind of metric or metrics that can describe linear approximations with their performance with regards to these networks. And I believe this will be a low-hanging fruit for us, because anything that some person or some small group in this group has to do is just run the linear approximations on top of these networks and these test cases and just report back to the group, and at the end of the day, if the group approves, into the report those metrics. And this would be, let's say, my idea in the framework of this group.
So I guess my initial thought there is that it's a very good idea, but it's maybe a little bit out of scope of what this task force is trying to achieve. I would highly encourage you to write a technical paper where you do this comparison and then make the statements you would like to make about how these different linear approximations may be misleading or better or worse in different ways. And then based on what happens in that paper, we may adopt maybe one new metric to use as a guide for filtering or not filtering data sets in and out of this, this benchmark library. But I think until that kind of basic comparison is done and the community has kind of blessed it through peer review or other means, it's maybe a bit premature to integrate it as a primary criterion for building the collection of cases. I think already you will get very interesting results in the cases we have already.
All right. So one other question. I don't know if anyone has any follow-up comments on this. There is another discussion or another question. I see someone unmuted themselves. Do you have some comments on this?
Yeah, hello.
Yep.
Hello, can you hear me?
Yes.
Yeah, hello. I'm Adam from Indian Institute of Technology, Kanpur, India. Is there any benchmark test system on multiple microgrids, is validating load flow and other similar studies? Is there any such benchmark test system in your repository?
So this repository focuses on ACOPF at the transmission level. So it would not be, microgrid is not like in the scope. There are other task force in IEEE that focus explicitly on microgrids and distribution systems. If you or someone else would like to propose a benchmark library in the form of this particular task force, that would surely be welcome. But you have to go through the 3 steps that are outlined above. You have to specify a specific mathematical program that you're going to optimize, and then you have to specify the standardized data format. And I think both of those tasks are non-trivial on the distribution level, but I'm surely, there's been a number of people who have expressed interest in distribution level OPF, so we could make a small team of people dedicated to putting that together.
Okay, actually we have developed a benchmark test system by integrating 4 different microgrids, and the concern paper has been published in one of the IEEE transactions. So we are thinking that it would be good if our benchmark test system included in any public repository, so that scholars will get benefited, whoever is working in the area. So I'd like to share you the link. You can have a look in that paper and pass it to that task force who is working on this network microgrids kind of thing.
Okay, I will happily do that for you.
Oh,
Great. So another question that is in the chat was talking about, again, building on this idea of just distribution OPF, not distributed OPF, which we'll talk about in another task force meeting today, but optimal power flow for distribution systems, asking about formats for the data sets, GridLabD, OpenDSS, SIME. What's the thoughts on, I know we don't have a distribution system OPF test case repository, but how would you, what are your thoughts on that, Carlton?
So I think it's difficult to make a choice there because I feel that, especially when it comes to like cost functions and trying to model distributed energy resources in a cost optimal way is not trivial, and there isn't great support in the current data formats. I think you could actually make a case that a new format is required specifically for distribution OPF. At Los Alamos, we have studied a variety. We use a variety of different distribution network formats, and we have concluded that OpenDSS is the data standard we're going to use for industry data sets. Our assessment is that no model is perfect, but if the core thing you want to do is solve a power flow or optimize over some collection of power flows, OpenDSS gives you the simplest model to specify a network's electrical parameters. So that's the one I might push for, at least initially. But if there was a collection of people interested and they decided, actually, we need to define a new format and this is what it's going to be, I would also think that's a very reasonable path, given how hard it is to specify a distribution OPF problem right now.
Yeah, I agree with you on that, Carlton. And I guess I would just add that I do think that's something that's really holding back or kind of a roadblock for doing distribution system optimal power flow is there's not an equivalent of the MAT power format or or these test cases. I think that's a very worthy goal. So good question. Another question.
Yeah, maybe I'll just add to this, like, if you're on the call and you were interested in contributing time to making a distribution OPF benchmark library that's analogous to this one, send me an email and I can try to connect maybe 4 or 5 people together who have this shared interest, and maybe we can make something happen.
Yeah, I would certainly be an eager consumer of that. I can't volunteer to do it right now, but I would love to see that happen.
That is usually the challenge, is who has some time to contribute to these things. Carry on, Dan.
So another question in the chat from Carlo. He says, I'd add to the conversation that the PGLib OPF results are useful to reviewers in the field when comparing new models. So there's more to it than just evaluating grids. Also, a 1% gap can be large for optimal power flow. So some more tight grids might be a worthy addition. You have some thoughts on that, Carlton?
I think I think they're great remarks. This is all true. It's a little bit, it's hard for me to make a call. I run a lot of experiments on these networks, and I kind of have my experience of doing OPF research for many years. And so I try to make the best balance of, are these interesting or are these not? If someone has a compelling case that here's a network with a small gap, but it's still super interesting, make that case and it will be included. I'm really just doing the best I can with my limited time and and the metrics that I have on hand. So I'm definitely open to extending metrics when people can make a case for it. So I think it's all good points. It's just not obvious to me, other than throwing everything in the kitchen sink in there, which I think could be bad. I think the consequences could be worse than the benefits. I'm not sure how to improve what I'm currently doing.
No, I think that makes sense, Carlton. One thing I would add to that is if there were some other features of these problems where even if the optimality gap is small, if you could show, for instance, that I'm not suggesting you do this, Carlton. I'm saying if somebody wants to include or make an argument for including some of these other test cases that maybe the optimality gap isn't showing interesting results for, we did some work before showing that the optimality gaps and the accuracy of the decision variables don't necessarily have to be strongly correlated. And so if there were some examples of case, I would have to dig up this paper and look at our results again to see exactly which cases those were, but there might be other interesting features where the optimality gaps are small, but there's still something interesting about those problems. I mean, as an example, if you were to do, say, transmission line switching, which I know is a little bit not, it's not in the problem description of the PGLib OPF bench test case, it might be the case that you could have a small optimality gap, but still have an interesting switching problem, for instance.
Yep.
And so if there were features like that, especially if anyone listening, knows of test cases like that have those characteristics, I would suggest that, please reach out to, well, Carlton's your best point of contact. You can also reach out to me too, but, and I don't know, I'd suggest it might be worth including those as well.
Yep, I agree. If people can make a case, and I think there is a case to be made for how close is the solution to like the relaxation to a real solution is an interesting metric. Please contact me and we can see about integrating it into the evaluation criteria.
All right. So I don't see any other questions at the moment, but I know people can be shy on WebEx sometimes. So maybe, are there any other thoughts or comments, or in the meantime, I can ask a question for Clayton. So Clayton, if you're still there, if you're still on, one thing I was wondering with the RTS data sets is how much. So you have this really nice, time series data, and you have kind of a lot more information in that case than you have in these other cases. If you wanted to modify some of these other cases, so say you wanted a similar time series style data for a different test case where we only have a snapshot, how realistic do you think, or how reasonable do you think it is, and maybe not to include it in the repository or in the benchmarking library, But just to generate a test case, how realistic do you think it is to take to sort of rescale other test cases according to the RTS time series data?
So I'll give an answer with a little background. So the way that we applied the time series data to the RTS was we took the line length information that's included in the RTS 96 data set, and we developed and we used like a graph layout algorithm to come up with node locations or relative node locations. And then we basically took that synthetic spatial data set and used GIS to plop it in a somewhat arbitrary location where I knew that there was interesting wind, load, and solar data. So that process basically got us geographically consistent or geospatially consistent wind, load, and solar, which is, I think, quite important to get the diversity of those resources and their correlations and consistency right. And so so that process, and then at the time when we did it originally, that process was difficult to automate because of where the wind, load, and solar data resided in those data sets that we drew from at NREL. I have long thought that process would be relatively easy to automate if you have a line length, data or some proxy for it, which Resistances does a decent job. Or node locations. If you just already have direct node locations, that works too. And the tools for accessing our wind and solar data sets have evolved pretty significantly in the last year or so. So I think that would be relatively easy process to automate and make use of. And then more directly answering your question, I think that is probably not it's okay for some test data sets, but it's probably not a great idea to just apply the RTS data directly to some other network. I know people have done it, and sure it makes sense, or sure it works, but I'm not sure that it does a great job of making sense. Especially if you're trying to get a decent analysis of unit commitment and ramping type patterns, intertemporal stuff. But I do think that one reasonable activity, although not entirely trivial, would be to develop a programmatic approach to basically drawing wind, load, and solar time series for these synthetic networks. And I think that would be really interesting and one worth undertaking, but one that I have not been able to do myself.
Yeah, that's really interesting to hear, Clayton. I appreciate the response. I do think it would be useful to have, especially as we have more synthetic networks with geographic data, to be able to have time series power flows and more kind of detailed. It would make it much more straightforward to generalize a lot of these cases into more time varying context. So that. Yeah, if I'm ever on a review panel for GMLC, I'll suggest that you guys get some more money for that.
So the one tool, NREL has recently provided open access, maybe open source, for a tool they call Renewable Energy Potential, or REV for voltage or potential. Okay. So REV. So we call it REV, and that provides a Python interface to our wind toolkit and our NSRDB solar data sets. So for at least wind and solar, that gives a really nice access to those time series. Load is a little bit different, so I'm not quite sure what to do with load, but it's also sometimes easier for these networks.
Got it. Well, that's really interesting. I wasn't aware of that, so I guess I'll just say thank you for all your work on that. I know it's not a trivial amount of effort.
Yeah.
All right,
relay
so,
the appreciation.
Carlton, so I don't see any other questions in the chat right now.
So I would just make one final call, which is if there are any strong objections to adopting the modifications to the repository that I've proposed, I need to hear them now, or it's going to go live shortly. I've heard some great feedback on how to improve the process, but no strong objections to the changes.
Going once. I don't know, Carlton, sounds good to me.
Great. Well, with that, I will thank you all for coming to this task force meeting. Hope to see you again next year. And in the meantime, I hope you enjoy the different repositories we're curating for benchmarking algorithms.
Thank you.
Well, thanks, everyone.